In this video, we are looking at the properties of rhombi, and they are also quadrilaterals. They have four sides, and they share the same properties as parallelograms. So you'll see this, that's why we had to start with parallelograms, because we have so many of our quadrilaterals that share those same properties. So opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary. That's where we see that big and small angle being formed. So we know a big and a small from parallel lines cut by transversal. They equal 180 degrees when we add them together. And the diagonals bisect each other. Okay, plus three additional properties. So all four sides are congruent. So this is basically a square that has been slanted. A rhombus is a parallelogram because we have opposite sides are parallel. We have two pair of parallel sides, but this is equal sides. So you're going to see it's basically a square that's we've been slanted, and then the diagonals are perpendicular now. If you remember, perpendicular notation is that upside down capital T, indicating that they form 90-degree angles. Since all the sides are the same, they're going to square up in the center when those diagonals intersect. They also bisect opposite angles. This is the first one that we are seeing that our angles are being bisected. So what that means here is, I'm just going to kind of draw a corner, that this angle's been cut in half. So if this is 22, this side is also 22. Okay, so that's what that means there. Okay, let's practice. Okay, the first thing I do is I always label what's given to me. Okay, so always take your time. I know JK is 12. JK is the top segment. And we know that opposite sides are congruent, so I'm going to go ahead and label the other side. Remember, once we have one, we go ahead and label everything else that we know is congruent to that. So that one's done. Now JN is this segment right here, is 7. Okay, well, knowing that our diagonals diagonals bisect each other, that means that this side is also 7. Okay, so what else? Oh, and diagonals are perpendicular. So where these intersect, they form 4 right triangles. Okay, so that's everything that's being given to me, but I need to go ahead and find some other segments. So what can I find here? Well, I was sitting here thinking, well, how am I going to find this other side after I spent all that time talking about all 4 sides are congruent? So if you know one side of a rhombus, you know all sides, because like I said, it's basically a square that's been slanted. So these are all 12. So what I'm looking for is this missing side right here. And how do we find a missing side of a right triangle? Well, we use Pythagorean theorem. So I'm going to go ahead and throw that out there again. Pythagorean theorem. Write it down. The more you write it, the more you know it. Is a squared plus b squared equals c squared. And remember, the only one that really matters which one you label is c has to be the hypotenuse, which is opposite the right angle. Okay, so which it looks like I know the hypotenuse. Trying to get it to focus for you here. So 12 is opposite the right angle, so that's my hypotenuse. So I'm going to just say 7 is A, and the unknown that I have colored in red is B. So I have 7 squared plus B squared equals C squared, which is 12. And I get 49 plus B squared equals 144. Now it's just solving algebraically. Rearrange. B squared equals 144 minus 49 is 95. Now the inverse operation of squaring a number is to take the square root of that number. So I will take the square root of this side. That's going to cancel my square. Whatever you do to one side, you do the other. So now I'll take the square root of 95. And I get approximately 9.75. I always like to go at least 2 place values. So that is this side right here, 9.75 approximately. So this one here is also approximately 9 75/100ths. So all of my sides are labeled, all my segments are labeled. Now I'm going to go ahead and answer these. And you'll notice that I always make sure my diagram is completely filled out before I go to answer over here. It's just a strategy I've learned that's really been helpful. Okay, JM, I'm going to trace that. JM is here, that is 12. Segment JL. JL is all the way across here, so 7 plus 7 for JL is 14. MN is this little segment right here, which is approximately 9 75/100ths. And then MK, trying to find me a different color here, is M to K is all the way across. So for MK, I'm going to say approximately 9.75, and I have that twice. So you can add it twice, or you can just multiply it by 2. And I'm going to keep my approximate symbol because I am just rounding away here, and we say that's approximately 19.5. Okay, moving on to number 4, we're going to focus on the angle properties. So I'm just going to glance back up here just to kind of get my brain focused on the angles, and we know consecutive angles are supplementary. That means like these corners here, where I have this small angle, and then these two make a big angle. I know together those equal 180. So I'm just going to make a mental note to look out for that. I also know that diagonals are bisect opposite angles. So opposite angles are bisected, so they've been cut in half. So what that means here is like angle 4 would be congruent to angle 5, because whatever they are total, it's been cut in half. So keep that in mind. What else did they say? We still have our perpendicular the diagonals bisect or intersect at perpendicular angles. So those are right triangles being formed there. Opposite angles are congruent. So that means that angle 4 plus angle 5 is the same as the opposite would be angle 3 plus 38 degrees. So opposite angles are congruent. Diagonals bisect each other. That's not going to be my angle. So you'll see I'm trying to say these things out, my thinking process out loud for you. So because that's what I want you guys to either be saying out loud or at least saying in your head as you're going through all of these steps. So let's go ahead and get started. Remember, start with the one that gives you the most information. So I know down here, I've been given that this is 38 degrees. So I'm going to automatically go ahead and label angle 3 as 38 degrees. And we know that opposite angles are congruent. So angle 5 is also 38 degrees and angle 4 is 38 degrees. Okay, so again, don't worry about answering all of this down here until you get your diagram completely filled out. So what else do we know? Well, if you know that two angles of a triangle, you can always find the third by subtracting their sum from 180. So I know 38 and 90, so I'm going to take 180 degrees minus 38 minus 90. And I get 48 degrees. So angle 1 is 48 degrees, which means, is it? Hang on. Okay, remember the calculator is only as smart as the person using it. I keep putting 138 in the calculator. I don't know if I said that out loud. So 180 minus 38 minus 90 is 52. So don't be afraid to, I just knew that didn't kind of add up in my head here. So don't be afraid to put it in the calculator a couple of times. I wrote it down right, but I was putting it on my calculator wrong, and so I had to kind of go back and compare. That's why I always ask you guys, please just jot down what you put in the calculator so I'll know that. All right, so that's fixed. Here we go. So I know that angle 2 is also 52 degrees, and opposite angles are congruent, so 52 degrees, 52 degrees. Everything is labeled. And then I know these are 90. So now it is time to start filling all of this stuff out here. I kind of like to color code it. It helps my brain a little bit. So measure of angle 1 is 52 degrees. This is where we put our degree sign. Measure of angle 2. Angle 2 is this guy right there. 52 degrees. Measure of angle 3. Right there, 38 degrees. Measure of angle 4, 38 degrees. I'm going to run out of colors though. It's a little darker orange. Measure of angle 5, 38 degrees. Measure of angle 6, 52 degrees. Measure of angle 7, 52 degrees. So you notice it's very easy to fill these out after my diagram is complete. So that's why I keep encouraging you, please do that. I'm getting to the point I won't even check your papers if your diagrams are not labeled. Measure 8, that guy right there, 90 degrees.